All right, so chapter 3 is exponentials and logs. Okay, we're going to learn how to evaluate, how to graph, how to solve each of these different types of things. So 3.1 is all about exponentials. 3.2, we switch over to logs and then blend the two together after that. So exponential functions are one in which you're raising a base to an exponent, okay? So just some vocab terminology there. The big number, so if it's f of x equals a to the x, the big number, the a, is called your base, and the x is obviously your exponent. They're functions, so you're going to get f of x, which can be interchanged with y. And your a is greater than 0. If there is a negative, it would be on the front of it, but the a itself would be positive. And it's not going to equal 1, because what happens when you raise 1 to a power? Always stays 1, which means it's a constant function. Constant function is not exponential, okay? So there's growth here, either in a positive, in an increasing or decreasing. So we start, this is where you need your calculator. Easy stuff, just typing it in. Just be careful how you type it in. It says evaluate the function at the indicated value of x and round your answers to 3 decimal places. So your graphing calculator, if you're using a graphing calculator, you'll type in the number like 0.5. And then you have that little caret button that looks like this. That's over the division, in between the division and the clear sign. And then you'll type your exponent in like 1.2, okay? So 0.5 raised to the 1.2, and you get 0.43527, so on and so forth. And then directions will tell you what to round it to. This time it says 3 decimal places. So I go to the 5, I look at the 2 is less than 5, which means I drop off the rest of the numbers and keep the 0.35. And yes, I'm going to be picky about rounding. If you round that incorrectly, that's wrong, okay? By now, hopefully we can round, and if rounding is not your thing, then make it your thing. With B, you can type it in exactly as you see it there in the graphing calculator, 150, and then 2, hit the little caret, and the negative 2.5. Make sure you use the negative and not the minus sign. So 150 times 2 to the negative 2.5. Good. 26.5165, and so on and so forth, which is going to round to 26.517. So sometimes, most of these will say 3 decimal places, but obviously just pay attention. When we get into problems involving money, there's no such thing as a third decimal when you're dealing with money, so you would round those to the dollar and cents. Questions so far? Easy stuff, right? That's just your calculator. Just don't plug it in wrong. That's when it stings. All right, now let's talk about graphing these things. So when I'm graphing an exponential function, they take on all of these properties that you see here. Number 1, domain of f of x equals b to the x consists of all real numbers. So these graphs on the bottom are what they look like, right? Increasing or decreasing with arrows at the end, which means that domain is going to be from left to right, all real numbers, negative infinity to positive infinity. There's no restriction on your domain. The range on your standard function, in which it starts right above 0 and continues up, or starts up and stops right above 0, the range is going to be from 0 to positive infinity. Obviously, that shifts when your graph shifts, which we'll talk about in a little bit, okay? But if my graph shifts up or down, that's going to affect my range. If it flips upside down, it's going to affect my range. Number 2, the graphs of all exponential functions of the form f of x equals b to the x pass through the point 0, 1. So if I look at this point, no matter what my exponential function is, whatever this number is, when I raise it to the 0, what do I get? 1. So this is always going to be part of your standard exponential function. That's your y-intercept. Again, that will shift when you start shifting vertically or horizontally. But your standard function, your parent function, will always have that 0, 1. Three says if b is greater than 1, so if my base is a number that's bigger than 1, then b to the x is a graph that goes up to the right and is an increasing function. So if I look at this first one, the blue one, okay, as I'm moving from left to right, it's increasing. This would be if my base was greater than 1. And then it says if b is in between 0 and 1, the graph goes down to the right. It's a decreasing function, so something like this, okay? And if you think about why that's happening, if I have a whole number like 3, the higher the exponent, the higher the number, right? 3 to the second is 9. 3 to the third, 27. It's going to increase as I move from left to right. But if my base is a fraction, what happens if I have 1/2 and I raise it to the second power? I get 1/4, right? And if I raise it to the third power? 1/8. What's happening to this fraction? It's getting smaller and smaller. So the higher the exponent on a fraction, the smaller the actual fraction becomes, right? So that's why it's decreasing as you move to the right. Number 5 says f of x equals b to the x is 1 to 1 and has an inverse. So if you remember going back to 1 to 1, our test for 1 to 1 was a horizontal line test, or if x is raised to an even power, x is an absolute value. Obviously, those things aren't happening here. So my initial function is 1 to 1. And then if I look at the inverse, if I were to switch the x and the y and solve for the new y, that function would also be, the inverse would also be a function, okay? So whether you're looking at the initial function or its inverse, they're both functions. And then the last thing says the graph of f of x equals b to the x approaches but does not touch the x-axis. So if I look at either of these, notice that they get close to but never actually touch my x-axis. I have a horizontal asymptote there. So if it's my standard exponential function, then my horizontal asymptote is at y equals 0. And that will shift with a vertical shift. So if it's not shifted up or down, then my horizontal asymptote is always y equals 0. Questions on that one? All right, so now actually graph these. So graph the exponential functions, and we're going to do this without our calculators because I would assume at this point on a quiz or a test I would not have a calculator, which means I use my T-chart, okay? So I start with our standard points, -1, 0, and 1. And I take those and plug them in. So 3 to the -1 is what? What happens when I have a negative exponent? Good. It becomes the fraction. So if it's in the numerator, it goes to the denominator, which makes this 1/3. So I get 1/3. 3 to the 0 is 1. 3 to the first is 3. And then I plot those 3 points. -1 and 1/3, 0, 1, and 1/3. And because I know it's exponential, I know the shape it's going to take on. There's arrows on both the left and the right, okay? And it's increasing. If I had kept going, if I had done the squared, it would have gone to 9, right? So it's increasing as you move to the right. With me so far? Yeah? Okay, so now let's talk about this function. What's the domain of this function? All real numbers, -∞ to +∞. What's the range of this function? Good. 0 to +∞, and 0 gets what? Good. A parentheses. Remember, that's an asymptote, but can't include that 0, right? There's no way to raise something to a power to make it 0. How about, where's my y-intercept? 0, 1. And where's my horizontal asymptote? Good. So y equals 0. So be prepared to answer all sorts of questions like that. Is there an x-intercept? No. Okay, it never crosses the x-axis. Good so far? Yeah? Okay, now you do B. Notice that exponent is now negative. Graph should look like this, right? If I plug in a -1, -1 becomes 1, that's 3. Plug in a negative 0, or plug in a 0, I get negative 0, which is just 0, which is 1. And plug in a 1, 3 to the negative 1, which is 1/3. So what's the difference between all the information over here and this graph? Does my domain stay the same? Yes. Does my range stay the same? Yep. Y-intercept? Yep. Horizontal asymptote? Yep. And x-intercept? Yeah. The only difference is the one on the left is increasing, the one on the right is decreasing, right? That's the only real difference. Make sense? Yes? Okay. So I'm going to cheat. We're going to do the first one quick, and then we'll see what happens when you do the second one, right? So if I do 1/4 to the negative 1, so it starts as a fraction, I do it to a negative 1, what happens to that fraction? Flips it so that it becomes a 4. Okay, 1/4 to the 0, 1. 1/4 to the first, 1/4. So my graph looks like this. Okay, second one, f of x to the equals 4 to the x. 4 to the negative 1, 1/4. 4 to the 0, 1. And 4 to the first, 4. Oops. Then it says draw the asymptote. So at y equals 0, I've got an asymptote. Okay, so look at the difference between these two, right? 1/4 can also be written as 4 to the negative 1, right? And if I were to raise that to the x power, I'd get 4 to the negative x. So if you compare these two, all that's happening is really that x has a negative on it, which is a reflection over the y-axis, okay? So hopefully that makes sense, because we're going to start to see we can use all the graphs of transformations, okay, to graph these functions just the same as we do with plugging in points. But if you know what a parent function looks like, you can shift it. It's just that you have to know what the parent function looks like first. All right, so every other graph that we have used transformations on, same rules apply. Vertical transformation happens after the exponent. So if it said adding a number, it moves up, minus moves down. Horizontal happens if it's in the exponent. So if I'm adding a number in the exponent, I move left. Subtracting it, I move right. There's two different kinds of reflection. One is upside down. So if my initial function looks like this, and there's a negative on the front, then it flips it so that it points upside down, like that. If there's a negative on the exponent, then it flips it left to right over the y-axis. So two different kinds of reflections. Vertical shrinking, or stretching and shrinking, if I've got a number on the front of my base, this means that if that number is bigger than 1, that it's going to increase faster, which makes it like somebody's pulling it from the top and the bottom, right? Stretching it out vertically. If that number was a fraction, it's shrinking it, like the ceiling and the floors are caving in and shrinking your exponential function. And then there's the horizontal stretch and shrink. The horizontal happens if the number's in the exponent. So if I had b, whatever that is, to the 2x, okay, it's actually the opposite. So if the number is bigger than 1, it's called a horizontal shrink, meaning the walls are caving in. And if the number is a fraction, then it's a horizontal stretch, like it's being pulled out from left to right. So let's start to apply some, right? So we know what f of x equals 4 to the x looks like. We've just done it. 1/4, 1, and 4. Now what happens when I add 3 to the end of it? Up 3 places. So 1, 2, 3 gets shifted up. 1, 2, 3 gets shifted up. 1, 2, 3 gets shifted up. And my new shifted function looks like that. What's the domain of the original one? All real numbers, negative infinity to positive infinity. What's the range of the original one? The original one. 0 to positive infinity. The range of the shifted one, 3 to infinity, and domain still the same, negative infinity to positive infinity. Okay? So when a vertical shift happens, the range changes, right? If it was flipped upside down, the order of the range changes. It would go negative infinity up to that line. And your horizontal asymptote moves with a vertical shift, right? So my horizontal asymptote that was at y equals 0 is now at y equals 3. My y-intercept that was at 0, 1 is now shifted up 3 places and is at 0.04, okay? So the vertical shift is what's going to cause a change in your range. Think about it. Your range is the y value, so that should make sense. And it's going to cause a shift in your horizontal asymptote and your y-intercept. Questions on that one? All right, so what's my shift look like this time? I'm going from f of x equals 4 to the x to f of g of x equals 4 to the x minus 2. What's the minus 2 in the exponent do? Good. What direction? Right or left? Right. Right, 2 places. So I'm going to plot the same parent function. And then I'm going to shift everything to the right 2 places. 1, 2, 1, 2, 1, 2. Maddie.
So if these are the numbers in the exponent, it's left to right?
Correct.
How is it done?
Correct. It's just like if it was inside the parentheses, the exponent is like your parentheses. So did my domain change? No, both negative infinity to positive infinity. Did my range change? Whoa, that's so sloppy. Sorry. My range did not change either, 0 to positive infinity for both, okay? Did my horizontal asymptote change? Nope, still y equals 0, okay? Did my y-intercept change? Yes. So initially it was 0, 1. If I wanted to find this exact spot, I would plug 0 in for y. In for x. And I'd get 4 to the negative 2, which is 1/16. 4. And again, neither have an an x-intercept because you can't get it to equal 0. Questions on anything we talked about so far? Okay, so we're going to stop here. We'll pick up on Monday. I opened up the 3-1 homework, so if you want to get a head start on it, you can. If you want to wait till Monday, that's your choice. Just don't whine to me about how long it took you to do your homework, okay? Obviously, I would start it now, and then we'll finish the notes on Monday. The one-to-one property says for a being greater than 0 and not equal to 1, so remember my base is going to be positive and it's not going to be 1, that a to the x equals a to the y if and only if x equals y. And all it means is that if my bases are the same, the exponents have to be the same in order for it to be equal, right? Which hopefully makes sense. If I had 2 to the third equals 2 to the x, and I wanted to solve for x, as soon as my bases are the same, I can literally ignore them and just grab the exponents, which would be x equals 3. Standardized tests love this stuff, and somebody confirmed it for me. There was something on a one-to-one property. Do you remember it? One-to-one property on Tuesday's PSAT if you took it. They said there was something on it. And then we talked about it already, but remember anything raised to the power of 0 is 1. There's no way to figure that out. You can't use a factor tree to figure out what something raised to 0 power is. It's a straight memorization, okay? So this one says solve using the one-to-one property. So I'm going to look at A. Are the bases the same? No. Is there a way to rewrite them so they are the same? Yeah. Yes. Do you change the smaller one or the bigger one? The bigger one. So 9 becomes what? 3 to the second. As soon as the bases are the same, I grab the exponents. X minus 2 equals 2. Solve, and x equals 4. These should be easy to check, right? Take the 30 seconds to plug it back in. 4 minus 2 is 2, and 3 squared is 9. Questions on that one? All right, B. Now I got a fraction on one side and a whole number on the other. Sometimes you change both, okay? So in order to get 2 to be 1/2 to become 2, I'd have to do what? Good. Oh, so you're doing the other side. Okay, so you can do these a lot of different ways. If I just want to bring 2 to the top, it's the same thing as saying 2 to the negative 1, right? And that's being raised to the x power. So this is the same thing as 2 to the negative x. So if the fraction throws you, get rid of it. Move it, and when you move it from top to bottom or bottom to top, it becomes a negative exponent. So now 16, let's say you don't know it off the top of your head, you can use a factor tree, right? This is 2 and 8, 2 and 4, 2 and 2. How many 2's are there? 4. So 16 is the same thing as 2 to the 4th. And then the bases are the same, so I grab the exponents. Negative x equals 4 and x equals negative 4. And just like a, you could take that and plug it back in. 1/2 to the negative 4 would be 2 to the 4th, which is 16. You can also move 16 to the bottom. So I can make it 1 over 16 by making it a negative exponent, like a negative 1 on the outside. And then rewrite 16 as 2 to the 4th. You can do this a lot of different ways. Okay, this is just one way. Questions on that one? Okay, and then C, 6 to the x equals 1. What do I have to raise 6 to get it to be 1? 0. And like I said, there's no way to like work that out. That's straight memorization. You got to know it. Still good? Yeah? Question? All right, the natural base E. So just like pi is a symbol that we use to represent a value, E is a symbol that we use to represent a value, okay? It's an irrational value. It never ends and it doesn't repeat. It's called the natural base. The 1, 2, 3, 4, 5, 6, the 9-digit estimate of it is 2.718281828, okay? The shorter estimate is just 2.72. So sometimes it'll just say approximated as 2.72, just like you approximate pi as 3.14. And when we use it in a function, that function is called the natural exponential function. This is the long explanation of where E comes from, okay? The good news is you never have to explain this to me, okay? But the values of 1 plus 1 over n raised to the n, where n is like the number in sequential order, okay? For increasing values of n, as you move towards infinity, meaning as the n gets bigger, you get closer and closer to this approximate value, which is 2.71828. Notice the starts to change very little at the end, okay? As you get bigger and bigger, the change is even smaller and smaller, okay? That's why it's called the natural base. It's a natural number that occurs by raising it to a higher power every time, okay? Just know, again, that we approximate it as 2.72. It's called the natural base, and there's a little button on your calculator that says ln, and above the ln is your E, okay? And that's the button that we're using. So when you have a calculator and you're asked to do something with E, you're never going to approximate it. You're never going to say 2.72 and then raise it to a power. Okay? You'll always use the button E just like you wouldn't use pi. You would use pi instead of 3.14 if you had your calculators. All right, so those questions will look something like that. Use a calculator to evaluate the function f of x equals e to the x at each value of x, and then round it to 3 decimal places. So to type that in your calculator, e to the x being e to the 4.2. In the graphing calculator, you have to hit second. And then the ln button, which is the third one from the bottom on the left-hand side. It's next to the 4. And then you should have your little exponent. You type in that 4.2 and hit enter. And you get 66.68663. So when I round it, I lose the 3, 66.686. The next one is 125E. So I do 125 seconds, ln, and then 0.05 times 30. And you get 560.211. So it's 560.211. So again, these should be easy. Give me questions involving your calculator. Just be careful not to type it in wrong. Okay? If you type in as a 0.5 instead of a 0.05.
I'm doing something wrong.
Let me see. All right, now we're going to use it to graph. So the question says use a graphing utility to construct a table of values for the function. It doesn't say to grab the table from the graphing utility. So you can use a graphing utility or a scientific in this case, but you're giving me the exact points, okay? Meaning plug them in using the calculator. Don't just go to your graph and get your table, okay? So I'm going to just plug them in. I'm going to start with -1, 0, and 1, just like we normally do, and I'm going to plug them each in. So 4, e -1 plus 2, 4, e 0 plus 2, and 4, e 1 plus 2. And you can literally type it in like that, or you can simplify first. It's totally up to you. So this is 10 point, I'm going to round it because I'm not going to get any closer than 0.87. So that's 10.9. 4 e to the second, 29.6. And 4 e to the third, 80.3. So obviously when I go to graph this, I'm going to adjust this graph. Okay, let's even say that this is 20, this is 40, this is 60, this is 80. So at -1, it's 10.9. At 0, it's 29.6. And at 1, it's 80.3. So if I just connect it that way, I lose that kind of L shape, right? But we know this is exponential. Even if the base is an e, that's still like just saying it's 2.7 to the x. This should still be exponential, so it should still have that bottomed out point. What would be the horizontal asymptote of this function? 0. There's no vertical shift, right? So I still want to go all the way down with my exponential function, even though it's not part of my points. So domain, all real numbers, range, 0 to positive infinity. Y-intercept is 0 and 29.6. Horizontal asymptote is at y equals 0. Questions? Everybody's good? Yes? Okay, so I'm actually going to stop there today because I did even less than that with A and C because of the college fair. So we'll stop there. We'll pick up with the interest problems on Monday. Your assignment is open, okay, on WebAssign for 3.1. You can do all but the interest problems at the end. My advice is do as much of it as you can over the weekend. If you save it for Monday, that's fine. Just don't whine to me about how much homework you have Monday night, okay? You do that to yourself.